It's a beautiful Sunday morning, a good morning from the Art of Engineering. I'm VK2AOE, and today's project is going to be QRPP to QRP. Okay, what's QRPP? For those that don't know, very, very low power, usually in the milliwatts. QRP is normally deemed to be 5 watts and below. Sometimes some people will say 10 watts and below. Now, the plan is to take this, the Mooncake transmitter, which transmits about 450 milliwatts, not megawatts, milliwatts, so less than half a watt. And I have made a completely homebrew QSO on this, about 100 kilometers away, using my chocolate box receiver and this transmitter, homebrew Morse key, homebrew antenna, and admittedly it was only 100 kilometers away, but I was very chuffed to actually be able to do that. But to make this more reliable, I really want to make it QRP, so get it up into the watts range. I have found that once you're around 5 watts, even 3 watts, QSOs on CW become very, very doable. My main rigs are my Oz QRP kits. They're both 5 watts, and I make lots of QSOs on those. So this circuit here, now you may notice that this circuit, which is going to take milliwatts in and give me watts out, is using an IRF 510, which is a MOSFET. And this circuit is care of VK3YE, who I have also chatted to on this transmitter. And we did that via an online SDR receiver.
Hello, that's George. Check out his YouTube channel, Art of Engineering.
So we sort of met in the middle with our reception, but transmission was direct, and he was QRP and I was QRPP, and it was very, very doable. So the values for this circuit here and the circuit itself, you will be able to find on his website, link below. And it's not a long video, but you can go to this point in the video. And at this point in the video, you'll see a circuit diagram and you'll be able to copy the values. Now, he's got this circuit running into a low pass filter, which is down here. Now, the low pass filter, I'm hoping you can see all of that, but if you can't, when you go to the video, you'll be able to see it. The low pass filter is going to cut off any harmonics. So obviously, being a responsible home brewer, you don't want to be transmitting on frequencies you're not meant to be on, or perhaps harmonics into other amateur bands, because you'll be calling CQ and someone will be trying to answer, but you're actually calling on another band altogether. So don't want to be doing that. This will cut off the harmonics at the pass and the spurious emissions that are happening higher up. And this circuit also does not have values on it, but go to the video. Now, I did not use the values in this low pass filter that Peter Parker has used, and there's nothing wrong with those values. But I wanted to point you towards another fantastic resource to teach you about home brewing, and that's Charlie Morris's site. He's a Kiwi ham radio operator, and he's got so many fantastic projects and explanations of how he builds. So it's not a direct how-to video. And I think with home brewing, build some kits and then start just trying to roll your own, looking at different websites, and just have a go. It's a lot of fun. You do make a lot of mistakes, but in the end, you get there. So I would suggest you go to that Charlie Morris video, link below. Have a look at that as well. He's got a lot of videos on how to make filters and how to homebrew rigs, and he goes through the whole process of what he's doing. So it's not this is how I did it, but he gives you so much information. It makes it very, very possible for you to utilize the circuits that he's using and put them to your own uses. So watch the videos. I always like to give credit where credit is due, and that is why I haven't put component values on these circuit diagrams, because you will at the very least go and have a look at those videos, and I think you'll be hooked. I think you'll start watching them in their entirety. Anyway, I will be showing you the build of this and how I get it to happen, and we'll then do a power comparison, and hopefully you will see me actually complete a QSO at several watts rather than just half a watt. Let's go. We've got the old TS520 powered up. We're back in the shack, and that is our homebrew 50 ohm dummy load. our AV 1000 meter. The 5-watt scale will take us up to there. So anything below that point there is the 1 watt point. Okay, so that's 1 watt. So if meter comes out about halfway, we're about 500 milliwatts. So let's power it up. Bit of side tone from the 520. Let's see what the power's doing. Well, there you go. So you can see there, like I said, about 450 milliwatts. By the time we fire up that IRF 510, I'm hoping that our needle's swinging up into this area here somewhere from 2 up to 5. That would be the dream come true. So you need a blade and a straight edge for this stuff, and score both sides on the same line. And it's obviously quite important to score the copper side, because you don't want the copper peeling off in a messy fashion. You want copper left on the board, not dangling off the board. So we'll get our I've already scored one side. If you're a younger person attempting this, I would say get someone to supervise you in this process, or get them to do it for you. But anyway, the teacher in me coming out. You just need to score along here. Keep your thumb out of the way. Make sure you've got a good amount of pressure on the ruler so it won't slip. And don't push too hard. Just keep doing lots and lots of passes. Make sure you've got a nice sharp blade. And we just keep doing that until we feel like we've worn a track in the board. And now here comes the fun part. We see if we can snap this without it breaking in a horrible fashion. So we get a nice straight edge on the desk. This is a workbench. I'm not too worried about roughing it up. You get your hand as close as you can to the edge so that it's not flexing the board in the wrong place, and you try and snap it. Not behaving like I would like it to. We might try it the other way. See if that's any easier. No. So we might need to... No, there it goes. So we just had to play mean with it. And there you go. Bit of extra for another project. Maybe the SSB double-side RAM transmitter. And we're going to ugly board on that piece of PCB. Now, I am a huge fan of this Dremel tool. I've used it for art purposes on numerous occasions to engrave glass. I like to do like engraved text on glass. Here's an example of said art, and it's hard to see, but when you have light shining on here, that says Temple Pig in glass. It's all engraved on the glass. So that's something that it's been very useful for. That's not actually the correct collar for this, so it's not in properly, but no, we're not going to get away with it. Need to change the collar. Much easier to show you than talk about it. Now, as I go, I meter to make sure that that island is separate from the earth plane. Just makes my life easier. Get ourselves in continuity mode. So if it beeps, we know that it's shorted to the island. So that's good. So now we'll just make 3 little pads where we'll mount our transistor. Now we just make sure that all those little islands are islands unto themselves. No, none of them are obviously they're all going to be open circuit to earth, because we've already tested that, but we just want to make sure that none of these beep when they're interconnected. So they're all isolated. So you'll now see that you've got 3 little islands there for the FET. And I'll do a few other little islands. I don't plan this out too much, because most of the time when you ugly build, the circuit components actually float above the board and use the leads to provide interconnections that float above the actual board. Some people like to have separate islands for each leg and etc., but there's nothing really ugly about that sort of build. So I tend to favor the organic approach and have it floating, and thus far it hasn't been an issue. It works for me, and it's nice to do what works for you. So if you like to make it nice and neat and have some little pads to put on there, I've seen some people that get a very small hole saw and they can cut little pads using the hole saw, which is probably a neater way of doing it. But this is the way I do it. And it's down and it's dirty and it does the job. Well, we've started the install of this PA stage into the QRPP transmitter to make it QRP. And as you can see, what's going on here is that is the FET. We're going to come in here with our QRPP. We have a 4-to-1 transformer here that outputs to this pi stage here, and they're your capacitors for the pi stage. This is a Charlie Morris low pass filter, and then outputs where it used to output to the switch, the transmit receive switching. So hopefully we've got, all I have to do now is throw 12 volts on this to power the FET and get our input of 450 milliwatts. And I'm hoping that capacitor values behave themselves and it couples nicely and it doesn't overcouple and load down the oscillator, but we shall see. That's all part of the fun of homebrew, is trying to get it to work. And sometimes it works first go and sometimes it doesn't, but that's okay, because every problem is an opportunity to learn. Houston, we have a problem. When I key down, the oscillator is working, but there is 0 amounts of power coming out. And I am assuming that is because the IRF 510 is not biased sufficiently and it's not switching on. Well, the IRF 510 amplifier section that I was trying to build, which we talked about at the beginning of the video, which is over my shoulder here, that has not worked out as I would have liked to have worked out. But I didn't follow the schematic that Peter gave. Peter's design was a very simple 2-transistor design, and he did say that he had not put in the RF biasing for this enhancement mode situation, and you would have to drive it very, very hard to get it to work, and that has its own risks as well. But this is probably what happens with a lot of Peter's designs. I think he spends a lot of time getting them as simple as possible. And with simplicity comes some problems sometimes with reliability of the design, especially with RF design. It's like black magic. You know, you only have to have one lead too long and you might have a self-oscillation or something going wrong. And then you have to try and find out a way of stopping that problem from occurring or improving that situation. So RF design, it's a journey of discovery. So if you want something that's going to work reliably, it's always good to start from the standpoint of a proven circuit and just build it as it's dictated. But where's the fun in that? I like to change things. And that's why I'm having a lot of problems, but I'm also learning a lot along the way. And you're coming on the journey with me to see the trials and tribulations. What I've done is I've gone back to Peter's site and I found a design that's got a BD139. We're going to readjust. Now, there's nothing wrong with this circuit, but the reason why we're going to readjust is because this circuit was originally intended for a different design, and I'm pretty sure that in my circumstances it's not going to work. But the actual circuits that this is used in, that Peter uses it in, he's got a 10-minute 5-watt transmitter, and he's also got a not so QRP 20-watt design. And both those designs are really interesting, and at some point in time I will most definitely revisit them and give them a crack, because they look like a heap of fun. Now, my sincere apologies for the noise. It is raining. We have a tin roof. It doesn't get much simpler than this, guys. It's a BD139. I'm using 0.5 millimeter enamel wire on all of these transformers and chokes. 10 turns to 4 turns. I think I may have made that 6 turns in my design, but it'll work with either. I was just trying to tweak things to get the maximum amount of power out. And this is the BD139. In the end, to get more power out, all I did was piggyback another transistor across the leads of this one. And what I also did was this resistor here, which was already a very low value, I made that dead short to earth And probably from an RF perspective, that's not ideal, but I was just trying to get as much power out as possible. And in my circumstances, it worked well. And that's what a lot of this RF design is about: is tweaking and changing values ever so slightly to get things to work. All the transformers and RF chokes were wound on two T50-43 toroids, which I got from mini kits. And this, obviously, this choke here is just to stop RF from heading off onto the supply and, heading it to the output. And with this design, in the end, you'll probably see, a bit of a spoiler alert, but we managed to get a good amount of power out of this. So keep watching and you'll see. And it's based on a QRP design that has previously been published. And it's probably going to give me a couple of watts rather than 5. But I think as a bipolar junction transistor, the BD139 is going to be a lot more forgiving and easier to get working. That's what I'm hoping. So I'm going to put 1 in this and see how many watts I can get out of it. If I can get over a watt, I'm going to class that as being successful. And we're then going to put the thing on the air and we're going to try and get a QSO. 2 watts would be really nice, because 2 watts CW, I'm banking on being able to use it to make QSOs. And I'm not saying it's going to be my everyday rig, but I'm gonna press it into service and see how many QSOs I can get on it, because I actually enjoy the challenge of using my own gear to get on the air. I will go to the bench, but yeah, we popped into JCar, my favorite place. As luck would have it, it's just across the road from the school I work at. And we got ourselves some BD139s, and I got 3 of those. And I may put more than 1 in the circuit, but to start with, I'm just going to put 1 in because I don't want to add complexity. And we got ourselves lots of resistors and capacitors and whatnot. So I'm hoping that we've got enough to convert that circuit that I started with, pop the IRF 510 out of it, pop a BD139 in, and a bit of coupling and some capacitors and some transformers. And let's hope that we have a QRPP transmitter that becomes a QRP transmitter, because it will be over a watt. And we'll see how much power we get. So it's getting towards 9:30 tonight. So I am virtually done. I have ended up, I know you can see there's a emitter resistor there, but I've basically gone emitter to ground. And I've piggybacked another BD139 on the back here. I'm sure that it's somewhat to do with coupling between the initial stages here and this PA stage, for want of a better word. But I'll show you what I'm getting out of it. It's giving me about 1.5 watts. So I am presently reasonably happy with that, because I'm going to shorten up my leads and pop this in the box, and I'm going to consider that a done deal. Okay, the PA stage is now in the box, and yes, it's ugly, very ugly construction. This is why they call it ugly construction, but this is uglier than ugly. This is ugly times 2. Anyway, let's get the lid on this thing and see how much power we're getting from it. When it was on the bench, it was giving 1.5. Hopefully shortened leads. I don't think it's going to give me that much more, but if it's over 1 watt, I'll be happy. I am a very happy chappy presently. I didn't think the leads would make such a big difference, but obviously with RF, there's RF leaking everywhere. Get a load of this. The bottom scale here is up to 5 watts. Look what I'm getting out of this thing. It's over 3 watts, nearly 3.5 watts.
This is on a CW filter through the Forster SDR. I'll just turn off the side tone on the TS520. Sounds alright, even the note sounds good, and it's that's on a CW filter on the SDR, and it's staying put, so that's also a good sign that we're not dragging the oscillator around, chirping and whatnot. Well, you're still here, so thank you for hanging around. Remember, if you haven't already, press the like and subscribe. I've had a huge amount of fun making this video. I was really surprised on a Thursday night sending out QRP requests for a QSO on CW that I would get a reply, especially a reply from Victoria. So I'm very happy about that. So thank you, Helen, for answering the call. Massive thank you, as always, to Peter Parker, VK3YE, for all the fantastic resources that are available on his YouTube channel and via the fantastic books that he makes. And also Charlie Morris. So I'm hoping that you've made the trip to those channels and started looking at the resources that are available there. And you are now down that fantastic rabbit hole of homebrewing RF. Stick to the lower HF bands to start with. I find that 3.5 megs, although the antenna is huge, it's very forgiving because it's a lower frequency. Probably 40 meters too, smaller antenna also, so that might be more doable on a smaller block. And just have fun with your home brewing, and I shall see you in the next video. This is VK2 AOE going QRT 73. Till next time.